So this is a very technical talk, but I'm going to try to make it understandable for everybody. There's a lot of code involved, but at the same time, the concepts are applicable, and I'm going to try to explain everything in a way that's understandable. So first, some background. Computers obviously work with binary, zeros and ones, but on a computer, it's easier to access groups of bits rather than individual bits. But for several reasons, working with individual bits can be very helpful. So I'm going to give just some interesting examples from some code I've run into previously. Okay, so let's say you've got several different types of enemies in your game. We've got grunts, elites, jackals, hunters, drones, brutes. Wait, okay, this isn't my game. That's okay. But just for example, you've got a list of types of things, which is very common. You know, usually you're going to have a variety of different pieces, or different enemies, or different characters, or different sorts of things. And so there's a lot of different reasons why it's going to be helpful to distinguish between things. So here's just our list of enemy types. Now, here's an example where, let's say you got some code where you're encountering an enemy, or your player encounters an enemy, or maybe let's say an AI player encounters an enemy. That's what I'm giving as a kind of a contrived example. Okay, so what this code says is, if the enemy is a grunt, a brute, a watcher, or a hunter, use strategy 1. Okay, we've got some other logic here. If the enemy is a spore, or if the enemy is a crawler, or a knight, or an elite, then do some other code. So the concept here is pretty straightforward. Just depending on the type of enemy you encounter, do some different code. This happens very frequently in games, obviously. Now, it can also happen where you can have many situations in your code where you've got to specify, the same stream of different conditions. It can come up many times, perhaps even very frequently. It might happen every time in your game loop, where you might have many AI characters that are doing this over and over again. So I'm going to present a different approach, or I guess harder to understand, but more efficient for the computer, and actually ends up being a little bit cleaner when you look at it. So here we're kind of further defining our enemy type. This is something most programming languages support. Is you can give exact numbers to a type. So when you do this, when you give the number 1 to grunt, that's represented here in binary as a 1 at the very end. That's the number 1 in binary. The number 2 in binary is this right here. The number 4 in binary is this, and so forth. These are going up by powers of 2, so 1, 2, 4, 8, 16, etc. The cool thing about this, you see this pattern here, though. A 1 goes in a unique spot for each of this. So I'm going to show you this here. What this allows you to do is you can pre-calculate different scenarios or different logical situations. So we're going to define situation number 1, which is a grunt, a brute, a watcher, or a hunter, like what we saw on a couple slides ago. We're going to pre-calculate that logical scenario. Going to pre-calculate it for situation 2 and situation 3. Here I'm using this vertical bar, which is common for many programming languages, is a bitwise OR, which for short sake, here's what situation calculates out to. You've got a 1 here, a 1 here, a 1 here, and a 1 here. If we hop back to the previous slide, those 1s correspond to the 1 for grunt, the 1 for hunter. It basically meshes them all together. Okay, when you do that, then your encounter enemy function becomes a little bit simpler. All you have to do is you have to compare the enemy that you're looking at with situation 1, or compare it with situation 2, or compare it with situation 3. Something about that is that in a computer, that's like a single instruction on the processor that happens like instantly. So that's cool. Here, getting into some deeper details. So let's say the enemy that we encountered was a hunter, which has this pattern right here in binary. Situation 1, I showed previously, it's got this pattern, and we're using the AND sign, which is it's a bit AND. So what it does is it takes the AND operation between these, and the result is just if it's got a 1 here and a 1 here, or if it matches up ones, then the result is going to have that. So here's our result, and then we're comparing that to basically we're trying to see, did we get anything in our result? And we did, so in that case, we're saying a hunter is inside of situation 1. Okay, here's my question. Well, you saw right here, we're limited in the number of bits we've got. We've got 32 bits. So what if you have more than 32 enemies? In some situations, you could work with 64 if you got a 64, or if you're using 64-bit data type. But let's say you've got hundreds of different enemies. So there's something you can use for that, what are referred to as bit arrays. A bit array is it's an abstract, it's a special data type that you've got it's made just for this kind of situation where you've got to work with individual bits, and there's lots of them. Almost all programming languages support these in some manner or another. Just for if you're familiar with these languages, these are the common implementations. But you can also implement your own if you want to. I'm going to show just here we're going to give an example with based on the same code we were just working with. By the way, everything I'm doing here is shown in C#. But again, this applies for really any language. So back to our list of enemies, but now imagine there were like hundreds or thousands of these. Okay, so you can say, all right, I need a giant bit array for situation number 1, I need a giant bit array for situation 2, and a giant bit array for situation number 3. Then what you can do, which is kind of verbose, but then you can go and specify grunt corresponds to situation 1, brute corresponds to situation 1, watcher 1, crawler 2, jackal 3, etc. So you're kind of pairing them that way. And finally, the result is it's very similar. You can just say, all right, we encountered this enemy, and then we can feed that enemy into our situation, and it'll tell us if it was set or not. So I guess the whole reason behind this is what I started off with. You could be checking all kinds of situations. In this really, really simple example, or in this example, the very code we started with is probably the easiest to write. It's also most likely the easiest to read. But sometimes you got a lot of conditions, and sometimes the computer has to do them very quickly or do them many, many times over. So, so that's the concept here. Any questions? All right, well, thank you.